Welcome everybody to the L2 Interop working group. We have 3 agenda items today, starting off with a brief review and just an overview on the wallet and privacy work. From there, we have Ian from Polymer on native Interop upgradability, and then finishing up with M-Team from Spire on based rollup and how this fits into the larger Interop vision. So starting off with privacy. Just briefly touching on the topic of privacy and the experimental wallet that that folks from the EF, Wonderland, Ambire, and others are working on. We shared a bit about this on the last call. For anyone that missed it, you can review the recap or recording from the last call. The TLDR is we are working on an experimental wallet, which is a fork of Ambire, to help accelerate work around interop and privacy. Going forward, the wallet will have a larger privacy focus, which we believe is something quite critical and valuable to accelerate. There were some recent understandable questions or concerns maybe raised around what exactly will this look like? How are we thinking about which privacy protocols to leverage? And just these kinds of things around, okay, yes, like I think many people here agree around privacy being an important thing and the wallet being a valuable vehicle for it, but there's some path dependence here and just some questions around what is this actually going to look like. So we may have Vitalik joining us to share his thoughts. I'm not sure if he's here right now. Vitalik, if you are, maybe unmute yourself and jump in. But otherwise, I think we also have some folks from the Wonderland team here. Yes. So maybe anyone from Wonderland, if you want to start off and share your thoughts around the wallet and kind of latest thinking around privacy there.
Hey everyone, I'm Gorilla from Wonderland. To give you a very brief summary for the ones who have not seen the previous one, the wallet will enable in terms of privacy, private sends and private receives. How can you send funds to another wallet without showing either the sender nor the receiver? And how can you make that with an amazing user experience, right? For example, how do you share your wallet address, like the stealth wallet address, so that anyone can send money to it and then it aggregates to your real private deposit address without people being able to link those two together. There is some protocols which are aiming to help expand privacy in the ecosystem, such as Railgun and privacy pools. The goal of the wallet is not to enshrine any of those, but to create the privacy standards so that any privacy protocol can build on top of this SDK that the wallet will integrate. Yes. The LDR of the SDK, it's literally the heart and soul of what we're doing. Yes, the wallet, like literally is the whole value of the Kohaku wallet, that SDK. Our aim is to move the ecosystem forward and to get wallets like MetaMask, Ravi, OKX, and many others to integrate this SDK and actually integrate privacy in an easier way. If they would like to do it right now, it'll be nearly impossible or very, very, very hard. So we want to make it easy, and to display the capabilities of that SDK, we will have the wallet prototype, which is the fork of Ambire. Did I miss anything, Josh, that you want to share? Or Skele, you want to add something?
No, I think you covered it. Skelly or anyone else want to jump in?
I can take the question from Frank though. What standards are needed? So we need a few things. The most important one is address derivation. So for you to be able in a non-interactive way find the, let's say, private key or secret that you will use to deposit for another person. This is something that we are working with, and it's similar to stealth addresses as you know it. There is also the standard of how do you communicate that secret to the receiver. For example, hey, I created this secret for you. How do you find that you now have an increase or a new node or a new private balance? And then there is a more boring standard, which is APIs and how does the wallet actually communicate with these privacy protocols, which is not so fancy, but it's something that we need to standardize as well for the SDK. And that's mainly it. We do have some components of chain regarding indexing and how to be able to, as privately as possible, not leak information when you're trying to find your secrets. But yeah, that's mainly it. We'll have more. We have some details on the ad reservation. We can share a document with you guys right now in the chat.
Thanks. Syke, did you want to jump in?
That's for me?
Yes, sorry. Yeah.
Awesome. Cool. Yeah. Hey everyone. So real quick, I just wanted to kind of give you a quick update on what we've been building so far. I think it's kind of relevant to our call. I posted very quickly on the chat group, I think last week, about that. So yeah, it's mostly related to privacy. What we are doing now is within Status Network. So Status Network is L2 based on the linear stack. We do gasless transactions natively, meaning like anyone can submit pre-transactions. We implement a spam protection backed by RLN, so ZKP, to guarantee that you're not spamming the network. And we also have Status as an app, right? Like the OG wallet. And so the goal now is to implement more privacy into what we're building. And one of the cool aspects of gasless transactions is that it re-anonymizes the wallets, because you can basically submit transactions from wallet that has 0 gas. And so it's not like with all the different privacy solutions that are currently implemented, where you always need to found somewhere a relayer, a bundler, something that will kind of take charge of that. And so that in the end, it kind of links to other wallets. And for the anonymity of the wallet, it's not very good. So with gasless transactions, we can really have like a pretty good anonymity set in the end. And so we're working now with Railgun to implement their solution at the kind of base layer on the L2, meaning that from the Status app and from any app that will be built on Status Network, you will have the choice to either go private or not. And so it's very early still, but it's just like I wanted to kind of get you guys feedback, or like at least let you know that, yeah, we're working on that direction, where we want to have private transactions and private app interactions built in at the wallet level, but also directly on the chain as well. And by the way, Linea, so we are based on the Linea stack. So Linea is also working with us on that. And they are currently implementing Railgun for the MetaMask cards. And so the goal is basically to also have it implemented at the MetaMask level. We're not there yet, but yeah, it's going to be, we're working on right now. So probably in the next few months, we'll have something to show.
Awesome. Thanks. Cool. Anything else on this topic?
Try our test nets. It's free. You don't have to bridge.
Sounds good. Cool. Well, if nothing else on privacy, we can move on to the next agenda item. I will hand it over to you, Ian.
Thanks. Let's see if I can share my screen. I haven't used Zoom.
Yeah. 1 second, I gotta let you. Okay, there you go.
Let's see if this works. Sorry, I've got to adjust my permissions on my computer. Quick. I'll have to leave and rejoin.
Yeah,
Apologies.
I also might be able to share. Oh, yeah, give me a second. And
Like macOS tells you to restart. I think you don't need to.
yeah, I was gonna say.
Oh, you've had the same experience?
Yeah, exactly.
Yeah.
Give them a minute. Oh, there we go.
Here we go. I think this will work now. Okay.
Perfect. Yep.
Yay.
Cool. See if I can. Busy. All right. Thank you. Sorry about that. So yeah, today I wanted to talk about something that I spoke about at Zoo Berlin, and I think I spoke to a number of you like separately as well about this topic. And so sort of the basis of this topic is assuming like the foundational axiom is that eventually we do want to achieve native interop between rollups. And by native interop, what I mean is interop that's verified as part of the L1 state transition function, under L1 consensus. And this is achieved. It's achieved using the outputs that rollups settle to the L1, and looks somewhat like this. And then, of course, other rollups can absorb those outputs into their own execution environment, whether this is done using L1S load or L1 origin. Once they have these roots inside their execution environment, you can verify arbitrary claims about the counterparty L2 inside of that L2 execution environment. So that looks great in theory, but there's this problem in practice that actually every rollup basically settles somewhere different and in a different format. So it's very heterogeneous, the layout of the outputs on the L1. And so it becomes quite difficult actually to deploy a contract on some L2 that is configured in a way that it can locate and make sense of the settled outputs of all of the other counterparty L2s. Essentially, what you need to do is you need to configure this verifier contract with a mapping of chain IDs to a location and a format that the L2 corresponding to that chain ID uses when it settles. And you could do this with your verifier contract up front. You can configure it with this information, but rollups are not ossified. So what happens when the one in the middle here changes, it upgrades from, let's say, OP Stack Bedrock to OP Stack Canon. Its settlement location, its settlement format, it changes in that process. Or what happens when a new L2 enters the system and we want to also connect with that L2? Well, we need to configure it as well. And so what this sort of necessitates in practice is that you have to have some upgradability in your native interop verifier contracts, because Ethereum is upgrading, the L2s are upgrading. And so these verifier contracts have to be able to upgrade in order to maintain parity with the system as it evolves. And this is obviously a bit of a problem because you don't actually achieve native interop, right? If you have a multi-sig somewhere in the system that allows for upgrades to occur. So is native interop even possible? Like, can we actually even achieve this in practice without a fully ossified system, without effectively having sharding? And I think that, I think this is something that everybody has come up across. Various teams have been working on native interop protocols such as Base's standard and Arbitrum's broadcast standard. And so anybody who's been working on a native interop protocol has surely ran into this. And I think, at a high level, there's basically like three ways that you address this. Either we standardize settlement, which probably never going to happen. You can have standardization within a cluster, this is kind of an argument actually in favor of like in-cluster interop, because part of what you solve in in-cluster interop is this problem. But you still need to interop between clusters, right? I think everybody on this call will agree that we're not all going to agree on a single rollup stack to use. But perhaps within different rollup stacks, there's a way of standardizing settlement logic such that it is shared across otherwise divergent stacks. And of course, native rollups are another opportunity where this type of the settlement logic could be standardized as part of a native rollup. It could actually be enforced through the native rollup precompiles potentially. So I think that's something to consider. But then again, you still have the problem where not every rollup is going to convert to a native rollup. And so you still have to have a way of bridging between the native rollup cluster and other clusters. So another way of approaching this would be to push the upgradability down to the L1 and have somewhat of like a configuration or a registry contract on the L1. And then you can actually use the L1 view or the L1 origin or L1 S load to prove updates to your routing in your system just based on changes in the configuration that occur in one place on the L1 in this L1 contract. You can absorb those changes into the L2s to affect those changes in the L2 contracts. And the advantage here is that by pushing the upgradability down to one place on the L1, well, it's easier to maintain like a better, like a higher quality security council to manage the upgrades of this single contract on the L1. You could potentially have like a consortium of like people from every major rollup who are part of this security council for this like shared registry contract on the L1. Or you could even take it a bit further. You could put it under the purview of the L1 fork choice rule, where this is like a system contract that gets upgraded only during hard forks, or according to the L1 validators, and that would truly put this under that would truly allow this to be native interop in the sense that it would be the L1 validators that are controlling this routing information. And then a third, and it's worth mentioning here that this has some overlap with the on-chain config work that's being led by Marissa, which is focused on the ERC 7785 right now. I think potentially we could add this information on top of the other information that's already stored in that config contract. And then the third approach, which is I think like the sexiest, best approach in theory, would be that every rollups sequencer, in the same way that they should be absorbing the L1 state root into their execution environment, according to the L1 origin, or in order to support the L1 origin, they could absorb essentially all of the settled outputs, the latest settled output for every other rollup that they're aware of, as part of their state transition function. And this has the advantage that it reduces the level of the number of levels of Merkle proofs that you have to provide to prove a counterparty state, because if you do it using the L1 origin view, or you do it based on having if you do it based on the L1 origin view, you first have to prove the settled L2 state inside of that L1 view, and then you prove your L2 state inside of that L2 state root that was in that output. But if you just absorbed the outputs directly into the L2 execution environment, then you would only have to provide a single Merkle proof against the L2 state root that was absorbed into the L2 execution environment. But I don't think this will work in practice, in part because some stacks, when they settle, you don't actually store like the actual roots in storage. You store like a hash of them or a commitment to them. And so it's not as simple as like reading from a location on the L1. You actually need to like run a full node for the L2 or communicate with a full node for the L2 in order to get the pre-image for the hash that was settled to the L1, because the actual L2 state root is not, present in a storage slot on the L1. Instead, it's a hash that commits to an object that contains that state root. So that's actually all the slides I have prepared. And yeah, I kind of just wanted to stop this and leave it as like an open question for discussion. I'm curious what other people are thinking about this. Maybe this is like a little too far out. I know it doesn't really relate to our current priorities of improving interop UX immediately, because this is a much further out problem. But if the goal long term is to support native interop, once we have real-time proving, et cetera, that has settlement times much lower than they are today, then this is something that we should start thinking about now, in my opinion.
Ethan, which of those options do you feel like is the most feasible as of right now? Two feels like the best way to deal with the variety amongst rollups, because 1 and 3 both just seem to have a lot of nuances for edge cases. But I'm curious which one you feel most optimistic about.
I agree with your analysis there. And actually, we've already implemented like a version of this registry contract. And I should add that like a lot of this was actually inspired by Arbitrum's prover pointers. And in a way, this registry on the L1 or this configuration contract on the L1 can be thought of like a global prover pointer that has been pushed down to the L1 instead of having to like maintain different prover pointers inside of the L2 execution environment. And I do think that like today, this is actually kind of the only way you can handle it. And yeah, I think the amount of standardization that would be required to handle it using the first or third approach is probably not achievable, or I'm doubtful that it is.
Got it. Yeah, that's helpful. And the pattern was a little bit familiar with Broadcaster. It makes a lot of sense, especially if you can just bank on the L1 being the best place to go to get that information reliably.
Yeah. Oh, thank you, Marissa.
Cool. Well, thank you, Ian. Any other? Oh, yes, Calvin.
Do you plan to propose an ERC or make this contract into an ERC maybe?
I think I'm kind of curious what people think the best route forward is, because yeah, I guess I don't want to spend too much time writing a standard if it's not something that people will actually like roll-up teams aren't actually going to adopt. So I think it's important that there's like some consensus arrived at ahead of time, so that we know that the standard will actually it'll actually amount to something, is my opinion. I think probably the best way forward would be to, I think, roll it together with the ongoing L1 chain config work that Marissa's leading. And yeah, perhaps it would be just an addition or amendment to the existing ERC, or maybe another ERC as well.
Okay.
Yeah, I can send the link to the group where we're starting to chat about some things.
Thank you. Yeah, I think that's a valid question. And like, yeah, the kind of the founding axiom, right, is that this is something that's worth pushing for. And I personally think that it is, but that's just my personal opinion.
I think you could also make the case that the relative size of a given cross chain, if it's just a transfer as the simplest use case, really plays a big part in what different, especially intent-driven solutions or even like native interop solutions you could use. If you have a very large amount, if you've got 100 million that you want to move between base and Arbitrum in either direction, then there are few solvers or well capitalized intermediaries that are able to make that happen today. via the routes that we're most optimistic about that solve most use cases. So I do like the idea of having something, albeit a bit slower, that could handle this in a more native way.
Yeah, I agree. And I guess personally at Polymer, we use a native route as a fallback for our faster route. So, if our fast route goes down, you can still progress using the slower native route. That's the idea.
Yeah, just wanted to echo Alan and Ian there. My view is that it's an important part of the broader Interop menu. So yeah, excited to keep pushing on this and see where it leads. And Marissa and the AA team at the EF have been doing a lot of great work here as well. Cool. Yeah, anything else on this topic? If not, we can move on to the final agenda item. Cool. All right. I will hand it over to M Team on base rollups and interop.
Cool. Can you guys see my screen?
Yes, perfect.
Great. Yeah, so that was a pretty technical just conversation from Ian, and I really appreciate that. But this is a lot more kind of high level. I just want to give my like summarized vision of how base rollups can fit into the interop story of Ethereum, which we've been talking about in these calls, but also how we can do that in like a more pragmatic way. Like I'm not going to be talking about narrative here or value accrual or anything like that. I want to focus on kind of a more product mindset. So the question I asked myself when I was making this presentation is, what is interop to me? I think we have all of us have kind of our own understandings of it, but the way that I look at it personally is that kind of as a user, occasionally I want to move assets from one app to another. That counts as interop. For me, it's not so much a chain. I guess it is like in practice, but for me, if I have my tokens in one area and I want to use them with another app, it's not because I just had them sitting around. It's because I was using them with another application. So just the other day, I was moving some tokens from Aave to Base because there was more yield on Base. And it wasn't because the instance of Aave on Ethereum was worse. It just wasn't my preference at the time. And so nothing about the chain was important for me. It was literally just the application and what each instance of the application could offer there. The other part of interop that I think is perhaps like underrepresented in the conversation sometimes, and Joseph from Inc had a really great presentation on this at ECC, is the idea of like composition of different actions among protocols. So we all know this as like being DeFi Legos, but just to expand on this, you can think of lots of different actions that you might have. You could have a swap, a deposit, a withdrawal, whatever. You could also just have a token. I think a token can be a representation of maybe like an LP position, and moving that across a protocol and moving these different representations across protocols with minimal friction, of course, is really powerful. So I think this is like, to me, this is what like interop being solved would mean, is that I can move my assets from one app to another, and I can move my actions across protocols and kind of compose across them. So maybe I do a leverage long using liquidity for multiple domains. And the point of like kind of where base rollups come in for me is doing this with like minimal necessary friction. I think there's a certain amount of kind of lock-in that we have for having multiple chains that are not necessarily the same. But I see this as there's a lot we can do before we run into those barriers. And so that's what I want to talk about for the rest of the presentation. But friction to me means like for developers, complexity of maybe doing message pathing or integrating intents. It means like backwards compatibility. So like does Aave on layer one work with my lock and mint protocol? So on and so forth. And I think that's at the end of the day, this ends up trickling up. And so we see complexity and friction for developers turning into delays for applications launching, and that's friction for users. And I think we see, personally, I think I see a lot of this in wallets, where a lot of complexity has been handed off to the wallets like MetaMask, and thus we've seen some delays in kind of what I'd like to see from wallets and kind of the user experience on that side. So yeah, let's like get into it. Base rollups, I think, fit in like three big ways, and then there's a few maybe second order effects that I want to keep thinking about. I kind of think of base rollups at the most basic level as multiplying whatever Ethereum is. So if Ethereum has fast slot time, base rollups can use that, export that sequencing, that building pipeline into something more. But if Ethereum has a negative aspects like a extractive builder market, then you'll multiply that as well. So you're just giving that to more block space. And there's pros and cons. The number one thing that I personally think about is this idea of like a composability zone or an area, maybe a set of chains that are synchronously composable between. And of course, there's different levels of this. Maybe you have crossing contract calls, maybe you don't. But from like a most basic level, I think people, especially Justin, use the term like universal synchronous composability, where you have Ethereum layer 1 includes all of the layer 2s, all the layer 3s, so on and so forth. They're all synchronously composable. I don't see this vision as being practical because I think there's going to be differences in how chains can express their preferences. But I do think that there are certain places where a like synchronously composable zone will make a lot of sense. So, for example, if you have a layer 2 and you'd like to have synchronously composable layer 3s, then you've built like a composable zone on top of these. Or maybe we just have a composability zone that doesn't include the layer 1, but does include a wide set of layer 2s. I think there's a lot of possibilities there, but for me, a base rollup is one way to export the sequencing of maybe a centralized sequencer or maybe a layer 1, and that gets us potential for these zones to form. Again, like coordinated by that sequencing aspect. I also think maybe one of the big ones for me is like reducing friction in a couple ways. I think this really starts to come out when you compare to asynchronous interop or interop across chains that are very different. So for developers, the biggest one for me is like if I'm attempting to engage with some protocol in another chain, that's my goal, or get my users tokens from another chain into my app, then there's a few different ways that I could attempt to do this with the technology that exists right now. But what probably ends up happening is that it looks like strange to me. It looks unknown because I hadn't seen maybe async programming practices in Solidity before. And so this kind of complexity is just friction. And maybe, I mean, for me, it's like if I'm working in Forge and I'm writing a smart contract, and I'm so used to doing synchronous contract calls because everything's usually in the same chain for, at least these tools are built for that mindset, that now we have this like disruption if there's some asynchronicity there. And I'm not saying this is like insurmountable. I just think it's friction. I also think backwards compatibility is like a really underrated part of super like interop focused teams sometimes, because we can develop like a great interop protocol, but I think it's really good to look at like what we actually want interop with. And for me personally, it's like pretty much the big DeFi protocols on layer 1, Aave, Uniswap. And if there's, these contracts are already written, a lot of times they're not upgradable. And so maintaining backwards compatibility, synchronous, asynchronous, whatever, with those is super important. And I think that base sequencing, again, does not guarantee this, but has the potential to enable greater backwards compatibility with the contracts and protocols we know and love. I also think base rollups are not a like front end thing in many cases. Like there's still, at least I hope, some form of chain abstraction or intent based routing on top of this. But I do think of base sequencing as potentially offering a way to do faster settlement of intents, for example. Maybe if you have a base rollup settles to Ethereum, so it's a layer 2, and you have another layer 2 that's not base, then interacting with the liquidity protocols, tokens, whatever, on this base layer 2 could be a lot simpler because you already know what to expect when interacting with Ethereum. Maybe you already have like a solver market built up for that. And so, connecting these dots is going to be a little bit easier for you. Again, especially if this is like a base rollup that follows the consensus and finality of Ethereum. I also want to link to this page right here where we've written a good bit about this at Spire, just kind of on the idea of synchronous composability and how we imagine it could be done for a base rollup, and then kind of what are some of the effects of that. So what are the trade-offs there? I think this is like everyone's mind kind of jumps to this when they hear the word base rollup, and so I want to just address some of these real quick. I think the first one, from my perspective, like the biggest one, is just there's been slow development, not only of base rollups but also of dependencies like pre-comps, slow development and slow adoption. ZK has not been necessarily slower than expected, but it's still nominally relatively slow process of getting these things production ready. And then moving on, I think number 2 here is maybe the hardest one to solve. The layer 1, and especially the block building pipeline, just isn't ready for DeFi at a lot of levels. I think that kind of democratizing maximal MEV extraction is a calculated trade-off that core devs made, but unfortunately has some second order effects. And so we've written more about this in this post here, but you can imagine that having an auction on layer 1 that's designed to extract value can make it difficult to run systems that are perhaps serving users that are expecting not to be front runner, to be sandwiched like they are in centralized sequencer layer 2s. And so at Spire, we've been doing a lot of layer 3, like base layer 3s on centralized sequencer layer 2s. There's a lot of benefits that we've written about. But essentially, I just want to kind of expand the idea of a base rollup to there's more composability zones than the original concept of like universal Ethereum synchronous composability. And maybe these sets join eventually, but for now I imagine that there's like these tighter knit areas that maybe don't include the layer 1 right now, just because of again that extractive sequencing market costs, block times, etc. I also want to talk about maybe a less obvious thing, which is the complex cost and fee structure. Not necessarily, I'm not trying to say that base rollups are necessarily more expensive than a centralized sequencer rollup, but designed poorly and especially designed naively, you will run into a lot of complexity issues. So if you're writing anything that interacts with layer 1, of course, you're going to need some way to pass the fees on to the layer 2 transactor. But if you don't have a single sequencer and like a place to conveniently do this, it can result in a mess. So I believe in most, if not all, OP-Stack rollups, the layer 2 data fee is passed on to users, but it's kind of like taken out of their account instead of a fee that they pay directly. And so this just additional complexity is the kind of thing you would see on base rollups. I think this is not unsolvable, and especially when we start to just reduce costs, gas fees on layer 1 with like a higher gas limit, this becomes like a lot more straightforward. But again, like whenever you have like a more distributed, decentralized sequencer or proposer layer, you're going to run into these types of complexity issues. So yeah, in summary, just want to make a few statements here. I think base rollups are one option for Interop compared to centralized or non-base shared sequencing. But they are unique. I think they have some properties that we aren't going to get anywhere else, and we aren't going to see in production. They also offer kind of like a moonshot, I think. Like I wouldn't put it as like a plan A for Ethereum wide interop, but more of like if this works with things like maybe a native rollup, it becomes a part of this. Then we have a way that could be way better than what we expected before, could get us a lot closer to like the execution sharding roadmap that Ethereum's been talking about for a while. And then I also think that we're going to see a lot more like isolated experiments, like base layer 3s on layer 2s that can show early value. So I think we'll get to see like the solidity flow of doing a cross-chain contract call before it's interacting with a layer one. So I'm personally really excited about that. That's one of the things we're building at Spire. And that should be coming soon. And then I also think that I said this a couple times, but I think base drops are a part of a larger picture of Interop. They're not the whole story by any means. And really the only thing they get you is this like coordinated sequencing layer, like shared sequencing did the same thing. And that's enough for starting to work on like an interop protocol on top of that. But you still need the interop protocol. You still need all of the infrastructure that we've been talking about in these calls. So chain abstraction, intents are both things that I would find very valuable for a world that even if everything is based. There is a potential world where a base and native rollup ends up becoming essentially an execution shard of the layer one execution zone. And we see these kind of like co-processor EVM environments being like the simple, elegant way of doing a rollup. And I think that's a potential future, but that would involve like a pretty major disruption in existing layer twos and not something that I'm personally betting on right now. That's it. Any questions?
Ernest?
So, Matthew, I think you know this concern of mine, but I wanted still to double down on what your vision is for the long-term world in terms of the number of synchronous composability zones. Like, would you be like in the Justin Drake camp of saying, hey, we can aim to have this like academically pleasing single composability zone to rule them all?
I think it's kind of an idealistic perspective, but still one worth like attempting. I mean, the big reason to consider Ethereum for like a big priority for your composability zone is as the network effect that Ethereum has. But again, we talked about some practical things that make that difficult, and I think we will end up seeing, whether I like it or not, we'll start seeing composability zones like synchronous composability zones that don't include Ethereum at first. So eventually, yeah, I'd love to do that. I think that's always going to be a part of our mission at Spire. But of course, there's practicality things we have to think about. I do think that it's kind of like a hub and spoke model that we can imagine here, where maybe there's a few large layer twos that have async interop with a layer one, but have their own composability zones with layer threes on top. I think something like Base could be, with our Base app chain's vision, could be something like a early prototype of that. But I'm not sure, again, how this like evolves in 5 to 10 year timelines. Great question.
I'm worried this is a bearish take because it means we can't hope to have a million times more transactions, right? If we keep this assumption of having a single entity to sequence the entirety of the execution zone, like this will be the bottleneck. So like this only works, like we will have this ceiling somewhere, which is why, yeah, I think it's a bit of a limited view, maybe.
Do you mean for just like a base rollup on a layer two, kind of being constrained by the layer one's resources?
Well, it doesn't matter. A world where a single entity has the ultimate power over how transactions are sequenced, which is a fundamental precondition to having shared sequencing or base sequencing in particular, right? So like it feels like from first principles, we don't really like my gut feeling is we don't want to build towards a world where we only have a single execution zone.
I think it's kind of a misconception that for a base world to exist, you need all sequencing rights and all the right locks to be given to the same entity for a slot. I wrote this article called Base Rollups Can Scale, actually, that addresses like this exact question from Anonymous Christopher goes. And I think that maybe the biggest thing here is like understanding that a base rollup is not guaranteeing that in the context of Ethereum, it's not guaranteeing that the layer one proposer, their layer one builder, has the right lock and is actually sequencing transactions and doing the heavy lifting there, but rather that they have coordination with whoever's doing that. And so, and there's another part of this, which is like the consensus and finality side. But the point is that the level of coordination that you need is not absolute. So it doesn't have to be you give over your entire block. I think it's maybe quite dangerous to imagine a world where we have like a super builder that builds everything, and I'd be quite against that. But again, I think perhaps we see a more distributed model. But again, it's hard to know. I think at first probably see there being enough room in like a centralized sequencer to juice more out of it for other chains. At Spire, we have a model that can do base sequencing but doesn't constrain the layer 2 sequencer at all. That'll be coming out soon. And so I think that it's kind of like I mean, you're correct that like if we want a full synchronous composability, then we need the right lock to be down to one entity. It's just like the same chain at that point. But that doesn't mean that you can't do anything without that being set up.
Well, that would be a redefinition of what base rollup means, right?
Yes. So this is a longer topic. I don't think that the original definition of base rollup from Justin is complete, and so I've attempted to define it in Spire's docs. I'll just put the link here. It has kind of an expansion of the idea. There's a few reasons why, but that's the big one is like the way that pre-conf designs have evolved makes, even from Justin, have changed like what a base rollup must mean. So there's kind of some self-conflicting things. And so I tried to lock it down a little bit more in that article, but I think you're right that going by that original definition, at least some interpretations of it, you'd have to have the way you described earlier with like a full right look.
Thank you.
So one thing I'm interested in asking Matthew about is the demo that Spire showed about reading the base layers data, Oracle data on the L3 or on the L2, whatever, on the rollup side. So what is your current approach from to do so? Are you like implementing L1 call or L1 S load or something like that, or what's your current approach?
Yeah, good question. We'll have a lot more talks about this soon. We have some stuff that's like just in the review phase, and so I can definitely share those when that's out. But for now, like I think it's easiest to understand the architecture as collapsing all layer 3 transactions into a single layer 3 block and then putting that on into a layer 2 transaction. And then each layer 2 transaction, it just becomes a part of the layer 2 block, I should say. And so if you were to expand all of this, you'd have a super block that includes like layer 2 and layer 3 transactions. Then what we do is we simulate that super block from like top to bottom. And every point that cross-chain call is being made, and we have like a Solidity interface for expressing that, then we just pretend that it's possible. So we say, if you're making a cross-chain call, let's just implement it on the let's run it against the other chain state, I should say. So we have like a cross-chain simulator that can handle this. And then once we're done that, we have this, like we know all the borders, all the places that we're making cross-chain calls, so we know what to expect from the results. And then we put those on chain into the layer 2 with what we call priming transactions that kind of preload state. And so in the model that you mentioned before of doing a layer 3 reading from the layer 2, we'd have a special priming transaction, it's like a system transaction for the layer 3 that would load the state of like the expected result from that call into the layer 3. and then the actual layer 3 transaction when it's executed could just read that state, and then we're during the settlement on the layer 2, which happens frequently because it's a base swap, we're verifying that the call was actually correct. So if you're making an Oracle read, you're going to have to check that the Oracle actually reads what you told the layer 3 it would read. So there's some level of prediction here, and then we have some alternate models for needing that eventually. It's not, just reading your question from the chat, it's not the same as what Gwyneth is doing. There's no new precompile, and we don't change the state transition at all. We're just using some tricks with like proxying and aliases, but it's not dissimilar either. It has some of the same characteristics for sure.
Thanks.
Anyone else? Any questions for M Team? Thanks for sharing the presentation. Yeah, my quick 2 cents for what it's worth. Not a particularly, I guess, insightful comment, but yeah, to me, base rollups are a no-brainer in terms of exploration, iteration. I think they've already delivered value on that front and pushed our thinking forward in many ways. Yourself, Tycho team, Ahmad, Nethermind team, many others working on this. I think it's already had a net positive output. Like you said, whether we call it a moonshot or something else, there's many things to still figure out around this, and where does this fit in? It's maybe a bit of a more medium to long-term effort, but yeah, I despite some of my questions or concerns, I support, and it's been great to see you and others pushing this forward.
Thank you. Yeah, I mean, I really appreciate that. I think there's like maybe a notable thing about base rollups is that there's other than Tycho, there's not a lot of large layer 2s or like established layer 2s that are directly pursuing this model in the short term. And so I think, and we had our, I think, sequencing call 17, where a bunch of big teams committed to eventually exploring this. But I think the general consensus has been, let's kind of wait and see how the layer 1 dependencies evolve, and kind of if we can do some further research here, which I think is definitely the pragmatic approach.
Yeah, makes sense. Cool. Well, we only have a couple minutes left. Any other quick questions, feedback, anything else for the group? If not, we can end things there. Cool. Thanks everybody for joining, and we'll see you next time.
Thanks, Josh.
Thank you. Bye, guys.
Thank you.
See ya.
Bye.